Hey there, welcome back. So, in the Commodore 64 course that I did earlier this year, there was an episode about sprite animation. Now, a few months ago, I think it was, I got a comment from a guy saying that it wasn't really the best episode. There wasn't a lot of visuals in that could, for example, show an example of an actual moving sprite. Maybe at the end of the episode, but the episode could have been better. So I went back and I watched that episode, and I have to agree with him. It wasn't the best episode in that series. So that's why I'm going to dedicate this entire episode to sprite animations for the Commodore 64. So let's just start right now looking at an example. So here we have a test system that I've made just to show sprite animation on the Commodore 64, and I'm going to use multicolor sprites. So let me just activate the first sprite here. So here we have a guy just bouncing around, and then I'm going to activate the next one. Then we have this spinning guy. Next one is doing something weird with his eyes. And finally, yeah, this guy. Now, this last guy, he is doing all of the animations combined. So basically, we have 4 different animation types here. So, and also, one more thing. They also have their own animation speed. I don't know if you can see it, but let's see. I think this guy has the slowest animation, and I think this guy has the fastest. But anyway, they have different animation types, and they have different animation speeds. But before we get into any code, and we look any deeper into this, let's just quickly take a look at the concept of animation. So, animation, as I'm sure you know, is just a series of frames played one after the other. In other words, we have pictures like this, where one picture is slightly different from the next one. And if we play these sequentially, and maybe even play them back and forth, then we can get this guy to move. So that's what we have to do on the Commodore 64. But unfortunately, there's nothing like a command that says animate this sprite. Or at least we have to make that command ourselves, with a macro, for example. The point is, we need to find a way to display these sprites one after the other. So, let's see how this looks when we play the animation. So, this is what we have to replicate on the Commodore 64. Making a series of frames and being able to play them sequentially so we can get this animation effect. So how do we do that? Well, since we are working with sprites, the first thing we should do is to open SpritePad. Or at least that's what I'm going to do. Because SpritePad is really good at keeping all the sprite graphics separated like this. And you can see them side by side. So, I'm not going to go into detail about how sprites work on the Commodore 64. I'm going to assume that you know how that works. But here in SpritePad, you can see that I have all of these different sprite graphics. And in fact, I have 14 different ones here. Now, like we talked about just a moment ago, you can see that each one of these are slightly different. These first 3, he's just moving his eyes. This little guy just moving his eyes. And then he bounces up like that. Then for the next one here, he's spinning around. like that. And you can see if we play them or if we view them one after the other, we can see some sort of animation effect over here. Of course, this isn't actual animation, this is just me displaying the sprite graphics sequentially. But hopefully you see the point. We have a few sprite graphics here, and basically we have now the basis. We have what we need to make these sprite animations. So what we need to do now is to make a system that will help us keep track of the different frames. So I'm gonna call this drawing a frame, this a frame. So every one of these is going to be a frame. Now the nice thing about SpritePad is if you look down here, when I hold my mouse pointer over one of these sprite graphics, you can actually see the sprite number starting at sprite 0 over here. So that's going to help us keep track of these different sprite graphics or frames. But what's the best way to keep track of numbers like that in assembly language? Well, in working with numbers like this, the absolute best way to keep track of numbers is by using tables. So we're going to make tables that's going to keep track of the different frames, different sprite graphics here. So we need to keep in mind what I said at the beginning, because there's a lot to keep track of here and it's very easy to get confused. But first of all, let's define a few things here. So like I said in the beginning, we have different sprite types. So I'm going to say that sprite type is going to be a table. So what type of animation type, not sprite type, but animation type. So animation type is going to be a table, and that table is going to keep track of what type of animation we're talking about. And then I need to define what that animation is. So for this first animation, it's going to be this frame, this frame, this frame, and this frame. So these first 4 sprite graphics, that's going to be my first animation type. Then this, and this. So these, what is it? 6. These 6 sprite graphics, it's going to be my second animation type. So we don't have to have a set number of frames for animation. This first animation is going to have 4 frames. This next one is going to have 6 frames. And then this one is going to have 4 frames. This is going to be the last animation type. And of course, like we saw in the beginning, we can combine all of these to make a more advanced animation type. So, how do we do this in assembly language, now that we understand the concept of how this is going to happen? Let's take a look. So here we have my project folder. First of all, let's just notice that I have separated things into different files. Not quite as much as we did when we were making the game for the course, but I've separated tables, constants, and macros into separate files. And of course, when I was working with SpritePad, I also exported the graphics to a binary file, .bin file. So constants, that's nothing special. That's just these default things for the Commodore 64, like for example screen border color. So instead of writing D020, I'm going to write screen border color to to make things more clear. So it's just things like that. And here in my tables folder, that's the important one that we're going to look at right now. So these are all my tables. First of all, let's start down here. So here we can see some of my main tables for the animations. So for example, this first one, this is a table called Sprite Anim Bounce. And here we have 1, 2, 3, 4, 5 entries in that table. Now the first four ones, first four numbers here, those are the frames for that animation type. So these are the numbers that I took from SpritePad. So the first frame, second frame, third and fourth frame. So what's this last thing, 255? Well, remember, we're making everything ourselves from scratch. So we need to just make up our own rules, right? And I made a rule here, excuse me. I made a rule here that says 255 is going to be a code. So it's just a number, of course, like any other number, but I have decided that 255 is going to be a code. So when my animation system reads 255 as a frame, then it's going to understand that now that's the end of the animation. So for every animation type, I'm going to use number 255 as the last entry in that table, because 255 in the system that I'm going to make right now, that's going to mean in this case, just in this case, that's going to mean the end of the animation. So if my animation system reads this 255, that's the end of the animation. So anyway, I made a table for every animation type. Sprite Anim Bounce, Sprite Anim Spin, Sprite Anim Wobble, and Sprite Anim Mix. And as I'm sure you can see, this is a very logical thing. We just plot in the frames that we want. So for example, this first one, frame 0, frame 1, frame 2, frame 3, and then 255 to specify that that's the end of the animation. Right, so we have these four tables with our animation types where we specify what frames to use. Great. Now what? Well, if we go up here, we have something. Actually, sorry, let's go. There are so many tables here. Yeah, here we go. Here's a table called Sprite Anim Type. This table is going to keep track of what animation type the different sprites have. So remember, on the Commodore 64 we can have 8 sprites simultaneously. So this table has 8 entries, and it has one entry for each sprite. So this table is going to keep track of what animation type each sprite has. So for example, this first entry here, that's what animation type sprite 0 has, the first sprite. And then sprite 1, sprite 2, and so on. So this table is just going to keep track of what animation type each sprite has. Now, you've seen these before. These are tables that we used in the course. It's just a table to keep track of the X and Y position for all the 8 sprites. But, so we have defined our tables with our animations here. We have a table with animation type here. But then we have something up here. Sprite Anim Low, Sprite Anim High. what's this all about? Well, these two tables, as you can see, they don't really have numbers here in my case. Of course, every table is going to be numbers in the end, but instead of writing numbers directly in here, I just say, give me the low byte of Sprite Anim Bounce. The Sprite Anim Bounce, that's a table down here. So, if you remember from the course, every time we use labels like this, with a colon at the end, that's a memory address in the Commodore 64. So we write the label to make it easy for ourselves, but in the end this is just a memory address. So what I'm saying up here, give me the low byte of that memory address, because memory address on the Commodore 64, that's 4 hexadecimal or 4 numbers in hexadecimal format. So let's just to avoid any kind of confusion, let's just do this. So for example, D020, D020, that's a memory address on the Commodore 64. When I say give me the low byte of a memory address, that's these two numbers on the right. When I say give me the high byte of that number, it's the two digits here on the left. So we have high byte, low byte, and then we have high byte for a memory address. So that's what I'm doing here. Low byte, low byte, low byte of these tables that contain our animations. Low byte of this, low byte of that, low byte of this, low byte of that, and the same with high byte. Now, why am I doing this? Well, this is let's just first of all repeat what we have talked about before. There's no one set way of doing things. This is just a way that I'm doing this right now. But what I'm doing right here now is that I'm simplifying the how this is going to work in the end. So by separating these in low and high bytes, I can say that I want sprite animation 0. That's going to be the first one. Sprite animation type 0. So if we load the first, the zeroth position here, the 0th position here, we can combine those two numbers using 0 page indexing. So if you remember, if we have low byte and high byte, we can combine them, and we can do something like this, for example. So if we have a 0 page address here, we can put that address in a colon, parentheses, put them in a parentheses, comma y. But of course, first we need to load y with, for example, 0. So, not going to go too much into detail about this, because this is a separate thing, right? It's 0 page indexing. But by doing it this way, I can load A with one specific thing. And in this case, it's going to be an animation type. And since we have so many tables here, we can't just say, load sprite anim wobble. Well, I can do that, but if as I load a sprite anim wobble, then I'm just going to get the first number here. And it's going to be really messy. If we set it up like this, with these two tables, keeping track of all animation types, I can select what animation type I want just by loading Y with that specific number. So for example, if I load Y with 1, then animation type 1 will be selected. So that might seem pretty logical. We have different animation types and we want to have a number for each of the animation types. But how does it actually work in the code? Well, it's kind of a basic zero-page indexing kind of thing. But let's just repeat some of the stuff we have been talking about before. So we have this zero-page indexing thing, right? And to use that, we need two memory addresses in zero page. In this case, I've chosen address 20 and 21. 20 is going to be the memory address 20 is going to have the low byte of a memory address. 21 is going to have the high byte of that memory address. So the way that works is that I, for example, when we say here, this symbol means low byte, right? So low byte of sprite anim bounds, which is a table down here. And I just, to use this as an example, I just set a random memory address here, just so that we can have a number. I don't know where this is in the RAM for real, right? But let's just imagine that it's at memory address 3856. So that's where this table starts. 3856. That's where we have sprite anim bounds. So the low byte of this memory address, that's 56. That's the low byte of this memory address. So that's the actual number that's stored here in this table. At the very first position here, we have the actual number that's stored into RAM is 56 here. In this table, sprite anim low. And for sprite anim high, that's the high byte. This symbol means high byte. So here we say high byte of sprite anim bounds. So it's the same table, but this time we want the high byte. So sprite anim bounds, the high byte is 38 in this example. So the number that's actually stored here into this position of the table is 38. So basically we have a memory address where this table starts. But we want to make this dynamic. So we have several tables. For example, here we have sprite anim bounds. That's one animation type. Then we have sprite anim spin. That's another animation type. So I want to have a dynamic system where I can address different tables. I don't want to write LDA sprite anim spin, comma X or whatever, because I have several tables like that. So in order to make this as dynamic as possible, we need to have tables that we have tables of tables, right? We need to have these extra tables so that we can dynamically address another table. So these two tables, sprite anim low, sprite anim high, are basically support tables, right? They just contain half of a memory address. This one contains the low byte, this one contains the high byte. So obviously we need to make sure that if we're loading the first entry here, then we need to load the first entry here when we combine them to get the correct memory address. So that's why I do it that way. Split it up like that, because I have several tables that I need to address, several different animation types. Every animation type has its own table. So when I write LDY 0, LDA CP anim low comma y. So remember this parenthesis thing, comma y, that's zero page addressing, indexing. This, when we write it like this, cp anim low, that's just a constant, right, for this memory address. So when we're using this zero page indexing thing, we need to specify the first. We always need two zero page addresses, but we need to use the first one of those two. That's the one we need to write here in parentheses. Now we don't have to worry too much about why, because this is just the way it works. So we need to write the first one in here. But I have a constant called cp anim low, so I'm gonna write that instead of 0020. Alright, so LDA cp anim low, this memory address, comma y. So in practice, that's this memory address, right? The one we have up here. Now, when we're using indexing like this, the comma y, that's the offset. And in this case, I loaded y with a 0. So the offset is 0. So basically no offset, right? So what are we going to end up with when I write this? LDY0, LDA, cp anim low, comma y. Well, we are here right now, right? Comma y, and y is 0. That means we are going to get the first entry here in this table. If I say LDY with 1, I'm going to get the second entry. LDY with 2, third entry, and so on. So every time I want to switch to another animation type, I need to make sure that these two are updated. So I need to make sure that cp anim low, this first 0 page address, I need to make sure that that is actually loaded with whatever animation type I want. Same thing for cp anim high, the 0 page address that contains the high byte of my memory address. So it's a little complex. You need to be kind of comfortable with 0 page indexing, but basically this is how I have set this up, right? We have all of these different tables with different animation types, but in order to have a simple way to address all of those tables, we also have these two support tables. This one with low byte of all of these other tables, this one with high byte of all of these other tables. So that's the basics of how this part of the code works. So now we know a little more about why I do it this way. We have these two extra tables to help us manage the other tables. So the tables with the actual animations, like for example sprite anim bounce, sprite anim spin, and so on. So these are the tables with the actual animation frames, but these two tables help us keep track of those other tables, so we can select another table. So that's how that works. But we talked about animation types, having different animation types. But we need something really essential when we're doing animation. And that's how we handle frames, the frames themselves, because that's of course what makes this animation. So let's look at that right now. Let's look at this drawing. So we have a drawing here, a little animation where a guy just bounces a little bit down and then back up again. So we have 5 frames of animation, and like we talked about, the last frame is going to say, okay, this is the end of the animation. So we have 5 frames, or 6 if you count the end code. But how are we going to handle this in the code? Well, I made 2 extra tables. This might be a little bit overkill, might be some optimization we could have done here, but this is how I did it in this case. So I have 2 more tables here. I have one table called Sprite Anim Frame Counter. This table is it has 8 entries. So once again, it's 1 entry for every sprite. We have 8 sprites. So this first entry, that's going to keep track of what frame number do we have currently have for sprite 0. So sprite 0 is now at frame number 0, so this one. But since this is an animation, it's gonna go up a frame, so then we will get to this frame, and then this frame, and this frame, and of course this frame, but this frame, we're at frame number 3. So when sprite 0 has this frame, we're going to have a 3 in here. Then we get to 4, 4, 5, so on. So each of the entries here just keeps track of what's the current frame for that particular sprite. So Sprite Anim Frame Counter just keeps track of what frame number each sprite currently has. So that keeps track of that. Now I made this extra table down here, Sprite Anim Frame. This is kind of the same thing, and this might be a little confusing, but this Sprite Anim Frame also has 8 entries. 1 entry for every sprite. But instead of the sprite number, this table keeps track of the number of the sprite graphic. So here, for example, sprite 0 has a number 2 here, because if you see the first frame here, the top row of numbers here, that's just the frame number, starting from 0, going up, so on. But the one down here, that's the number of the actual graphic. So if we go over to SpritePad now, we talked about that we can see the number of the sprite graphic down here. So we don't have to make animations like, oh, this frame, then this frame, then this frame, then this frame. You know, we don't have to do it like that. We can mix and match. We can make an animation, oh, I want this one, but then I want that one, and then this one and that one, and I want to make that an animation. And by doing it that way, we don't have sequential numbers like that. So, but that's no problem, right? We have these great tables that we made, so we can plot in whatever numbers we want here. It just so happens in this example that the numbers are sequential. Here they are sequential, here they are sequential, until we get to here. So I think I said something wrong last time. I said that this animation included this frame, but it doesn't. That was wrong. This animation includes the spin animation includes this one, this one, this one, this one, this one, and this one. So that's why we have a 0 down here. So the point is, you can mix and match like that when we're doing tables like this. So that's why I made this extra table, to keep track of what graphic number this sprite currently has. Now the reason I said that it's a little overkill, we can do a little optimization, we're going to come back to that in a second. But for now, you just need to understand that we have one table to keep track of the frame number, and the other table is going to keep track of, okay, so you're at frame, we have a certain animation, for example spin animation or whatever, and at frame 0 on that spin animation we have sprite graphic number 2, which in this case would be 0, 1, 2. It will be this one. So 2 more tables to keep track of that. Alright, so we have those tables. Let's see, animation type, we looked at that one. So we have a lot of tables here, but hopefully you're starting to understand what these tables are used for. For example, this one, basically all of these have 8 entries, because each of these entries is for each of the 8 sprites. And this one just keeps track of what animation type we have. This one keeps track of what we just talked about. It's gonna keep track of what the actual graphic number for that animation is. And then we have this animation frame counter, which is gonna keep track of what position in the animation are we at right now. What's the frame number? So that's what that table does. And then of course we have the animation speed, and animation timer is a part of that speed thing. So that's basically the whole thing there. It looks a little intimidating because it's a lot of tables and it seems a little complex, but it's not that bad really. Of course, we have to be comfortable working with assembly tables. But basically, that's what we have when it comes to how the animation works when it comes to tables. So those are the tables that we have to work with. Sprite binary, let's not worry about that for now. Sprite animation speed and animation timer, we're going to look at that in just a second. But before we go any further, let's just make absolutely sure that we know how to place a sprite on the screen. Because that's such a fundamental thing that if we don't know how to put a sprite on the screen, then this whole animation thing is going to be really tough. So I made a very simple program here. All it does, it just let me just run this now. So all this code does is place a sprite on the screen. And there we go. So it just places one sprite here. But since I'm using multicolor sprites, I need to do a few extra things. So here, for example, I'm setting the color for extra color 1. Here I'm setting the color for extra color 2, because I want those to be black and white. But I also set the color for the sprite itself. I want this to be red. Other than that, I just set the X and Y position. But then we get to the important part down here. So hopefully you remember this thing about sprite pointers, because that's the whole thing here that we have to work with. Sprite pointer points to where in the Commodore 64 RAM the sprite graphic that we want to use is located. And here at the very bottom here, we can see that I put my sprite graphics, the one that I exported from SpritePad, I put those at memory address 2000. Now, how does this work? Well, hopefully you remember that in order to find what I call sprite pointer index, we need to take the let's just bring up a calculator. So we need to to take the memory address where we put the sprite graphics, which is in this case is 2000, memory address 2000. Then we need to divide that number by 64, but 64 in decimal. So 64 in decimal, that will be 40 in hexadecimal, and hexadecimal is what we're using down here when we are dealing with memory addresses. So if I divide this number with 64 or 40 in hexadecimal, then I'll get the sprite pointer index. So I'm just going to divide 2000, hexadecimal 2000, I'm going to divide that by hexadecimal 40. Then I get hexadecimal 80, which is what I'm using up here. So why 64? Well, basically that's because 64, that's 64 bytes. That's the size of one sprite graphic. So once again, let's not go too much into detail about that stuff. Okay, so we take this so-called sprite pointer index, and then I store that into the sprite pointer, in this case for sprite 0. So sprite pointers by default, they start at 07F8. That's a sprite pointer for sprite 0. And then we go to let me just copy this. Whoa. So sprite 0, that's 07F8. Sprite 1, that's 07F9. Sprite 2, that's 07FA. Sprite 3, that's 07FB, and so on. So there's a memory address. That's the sprite pointer for all of the 8 sprites. Now when I say store hexadecimal 80 in the sprite pointer address, that means that we will get this graphic, the very first one. That's what's at the beginning of the memory address 2000. So I squeezed my graphics into memory address 2000. So memory address 2000 starts here, and then we just go all the way here. But we go in increments of 64 bytes. So we have this one, which is 64 bytes, then this one, 64 bytes, so on. So this is the first index. Now, if I wanted, so let's run this. Let's run this code once more. Oh, I have 2. Okay. So now I have this guy, right? That's the first one. That's this one. But let's change to this one, the one that's stretched like that. And if we look down here, when I hold my mouse pointer over here, that's sprite 3. Okay, fine. What I'm going to do now is, let me just close this one and this one. Yeah. So in order to use this graphic, I just add the sprite number down here to the sprite pointer index number. So we have 0, 1, 2, 3. Or in our case, it's 80 here. Sprite pointer index is 80. So we have 80, 81, 82, 83. So if I change my sprite pointer index now to 83, I should get this sprite graphic when I run the code. So I'm gonna do that right now. I'm gonna change this from 80 to 83. I'm gonna save that, and I'm gonna run the code again. Hopefully we'll get a stretched sprite graphic now. And we do. I don't know how to, maybe I can make it a little bit bigger. So, alright, so now you see we have this stretched sprite. So, now we know how the sprite pointer index thing works. We could just say, let me just remove this comment. So what we could do, of course, was to say load A with 80, sprite pointer index, the very start of the graphics. So I say load A with 80, then I say clear carry, add with carry, and I just add the number 3, which is the number of this one, 0, 1, 2, 3. And of course I store that in the sprite pointer for sprite 0. So that would be another way of doing it. And this might seem once again a little bit of overkill. Why would I do it this way? Why don't I just write 83 here, right? Well, again, it's to make this dynamic, because I don't always want sprite graphic 83. I don't always want this one. So the reason I'm explaining this now is, let's just close this example. It's because now we're going to take a look at the actual code here for the animation. So of course you know that in order to do anything when we're working with assembly language, we need to do a lot of stuff before we can do some stuff, right? So here I'm just enabling multicolor for all sprites. But here I set up the raster interrupts. So hopefully you remember about the raster interrupts. We're not going to be talking about that right now, but there's a subroutine down here that sets up the raster interrupts. So we're going to be using raster interrupts. Alright. And then I do this same thing like I did before. I set up the extra color for extra color 1 and extra color 2. And of course, as you know, those are shared with, by all sprites. We're using multicolor for all sprites, so we need to set the extra colors that we need. Then I set up some information here for sprite 0. I load X with 0 because that's how I want my system to work. I want the X register to use the X register to keep track of what sprite I'm currently on right now. In this case, actually, yeah, I didn't have to do it in this case. Let's just remove this. So what I'm doing here, I'm just setting the sprite color for sprite 0 to red. I'm setting the X position and I'm setting the Y position for sprite 0. And down here I'm enabling sprite 0. So very basic stuff really. Then we get down here. So this is the game loop. This is the main thing that's repeating over and over and over again. So what's happening in here? Well, I say LDX 0. So load X with 0, but then I have a macro here, set sprite animation. But I said that we didn't have that sort of thing. Well, if you remember that I said that, then you probably also remember that I said we have to make that stuff ourselves. So I made this macro called set sprite animation. So what that macro does, it takes two arguments here. The first one, this one, that's what's the animation type. In this case, it's animation type 0. What's the animation speed? In this case, it's 10. And that's all that happens in this loop. Load X with 0, and I run this macro. And then we just jump back up here. This goes over and over and over again. So, that's the main thing. Let's look at this macro, set sprite animation. As you can see, it's really simple. We take two arguments, type and speed. So what do? Well, we just load A with the type, the animation type. We store that into the table called sprite anim type. And as you remember, we have a table that's going to keep track of what animation type we have at the current time that we have for each of our 8 sprites. Right, that's what this table keeps track of. So we remember, right before I ran this macro, I loaded x with 0. So whatever I put into this macro, that's going to apply to sprite 0. So we load x with 0, and when we get down here, store this animation type, sprite anim type comma x. So this is going to apply to sprite 0. And we just do the same thing with the animation speed. So for sprite 0. So it's just LDA STA, LDA STA. Really simple. So that's all that macro does. But this doesn't really make any sense, does it? We don't do anything here. We just set the animation type and the animation speed. Nothing else happens there, right? Just goes over and over again, setting animation type and setting animation speed. Well, here's the magic. If you remember what I said just a moment ago, I said that we're going to be using raster interrupts. Hopefully you know what that is, and if you don't, I have a video about that. So just go back and watch that video. But as you know, sprite interrupts, it's like we have two codes, let's just call it that. We have a main code and we have a sprite interrupt code. And it seems like they're running at the same time, but what's happening is the computer switches really fast between these two codes. This is our main code. This is what's running all the time. But every 60 seconds on NTSC or every 50 seconds on PAL systems, we get a little interrupt where we run a raster interrupt code. And the way I set the raster interrupt here is that when the scan line reaches scan line number 240, that's when the raster interrupt is triggered. And that's going to happen 50 or 60 times every second. So, what's the actual code here in the raster interrupt? Let's see here. We have a raster interrupt routine. First of all, we just acknowledge the raster interrupt, and then we have an interrupt return. So that's the raster interrupt stuff. But the main part here is this one. We jump to subroutine. So we're running a subroutine here called Sprite Animation. We're running that subroutine inside a raster interrupt routine. First of all, why am I doing this in raster interrupt? Well, it's because in the raster interrupt routine, we can do stuff that if we didn't do it in the raster interrupt, if we did it in the main code here, there's a very big chance that we would have graphical glitches or sprite tearing, stuff like that, because the screen is being updated all the time. And we don't know when this is going to happen. The machine just processes through all the code as quickly as it can. So it's going to update this all the time. But if we do this in the interrupt routine, we know that it's going to happen. This code is going to run when the scan line is down at scan line 240, which is pretty much at the bottom of the screen. So if our code runs there, if we change the sprite graphic, if our character goes from this to this, whatever, the next frame, right? If that happens in the interrupt routine, that's not going to be displayed on the screen as it happens. Remember, it happens really fast. So it's gonna switch to the next graphic, and then we go back from the interrupt routine and go to our main code again, because that's how raster interrupt works. So we're going back and forth like that. But every time a sprite graphic is updated, it happens here in raster interrupt. So it's not going to, we're not going to change a sprite graphic as the screen is being updated. Because like I said, if the scan line hits the sprite just as it changes from this to this or whatever, that's going to cause some sprite tearing, whatever. It's not going to look good. So that's the reason why we do it in raster interrupts. Okay, so that's raster interrupts, but what is this sprite animation routine? What's the actual thing here? Right, let's go to our sprite animation routine. It's not super big, it's just this thing here. So, sprite animation. Basically this is just a loop. Sprite animation loop. We start at 0, and we just go over and over again here until we get to 8, which is the max number of sprites. So this is a loop that's going to run 8 times. It's going to run once for every sprite. We start with sprite 0. So what happens in here? Well, this is where all our tables comes in. We talked a lot about tables, and this is where we're actually using them. So what's happening here? We're loading Y with sprite animation type comma X. So X right now is 0, and the next time this loop runs, of course, it's going to be 1. Next time after that, it's going to be 2, and so on. So, but now it's 0. So sprite animation type. We're loading the sprite animation type for sprite 0 now, loading that into Y. So we're loading the animation type of sprite 0, and then we say, okay, load A with sprite anim low, comma Y. Let's go back to our tables, sprite anim low, comma Y. So load Y with sprite animation type. What animation type number? Right? Well, I want animation type 2. So that's 0, 1, 2. That's this one. So whatever is in here, in sprite anim low, because I want to use sprite anim wobble, that animation type. That's animation type 2. So I, based on what animation type I have in this table, I load the low byte, store that into the 0 page address for the low byte, and I do the same thing for the high byte. So animation type 0, 1, 2. So I load that, store that into the second 0 page address. So now we have 1/2 of the memory address here, half on the memory address there. So we store those in those two 0 page memory addresses. Right, so now that's set up. Now we know what animation type, or we have set a certain animation type there. Then we say, okay, load Y with sprite animation frame counter, comma X. Still working with sprite 0 now, so sprite animation frame counter. That was this one. That table keeps track of what animation frame are we at right now. So we're loading Y with the animation frame number, and then we say, alright, load A with, now this is the 0 page index thing, right? So whatever we set up here with the animation type, whatever we set up there with the offset of Y here. What's Y? That's the current animation frame. So the current animation frame is our offset for this table that we're loading from right now. So if this was animation frame, if this was frame number 2, Then we would load this table that we have right now with an offset of 2. Hopefully that makes sense. Let's not go too much into this zero page index thing, because like I said, it's a thing all on its own here. So if you don't know about that, then I recommend that you read up on zero page indexed addressing. Right. Anyway, what's actually going on here? What are we actually doing? I said we're loading from table with an offset, but what table? Well, we just set up here what animation type we wanted to use, and we set up our zero page system for a certain table. So I said that I wanted to use this wobble thing, which means that because we set this up here with the zero page thing, we're at this table right now, Sprite Anim Wobble. So when I say LDA CP Anim Low, in this case, it's actually this table, Sprite Anim Wobble, because of what we did up here. So I'm loading from that table with the offset of Y. Offset of Y, like I said, is the animation frame number that we're currently at. So let's say we're at animation frame number 2. That means that, like I said, we have this table, but we are going to load offset 0, 1, 2. So this is the number we're actually gonna get right now, 11. So I'm loading 11 in here, and I'm storing that into Sprite Anim Frame, X. So I'm storing that as the actual graphic for Sprite 0. Then I say, okay, compare that, and remember, when in this case, Sprite Anim Frame, that's the actual graphic number in here. So I'm storing that into there. And then I say, wait a minute, is this 255? Is this the end of the animation? 255 is my code for the end of the animation. Right? So we have these graphic numbers down here. So we're reading them in. But if we're reading in a number like that and we say, whoa, it's 255, then we know that it's the end of the animation. We don't want to continue. So it's the end of the animation, but if it's not the end of the animation, then we just branch down here. Not end of animation. So what happens if it's not the end of the animation? Well, if it's not the end of the animation, then I say load sprite pointer index, and I add sprite animation frame. Sprite pointer index, that's going to be the same. That's always going to be this hexadecimal 80 in this case. So we have hexadecimal 80, that's not going to change. But in addition to that, I'm adding sprite anim frame. I'm adding this graphic number that we got. So that what we're going to get is like we did in the example just a minute ago. We have this sprite pointer index plus the animation number 0, 1, 2, 3, for example. So it's going to be just the same as we did in the example, 80 plus 3. And that's let's see, where are we? Yeah, and that's what I store in the sprite pointer right now. Now we're actually setting the graphic for the sprite 0 in this case. And then we say check the animation timer. So we have this thing called sprite anim timer, X. This is just a thing that's going to count up. What's it going to count up to? Well, then we have this thing called sprite anim speed. This sprite anim speed table, sprite anim speed, this will have the animation speed for each of the 8 sprites. And that's something we can change dynamically. If we have an animation that we want to play quickly, then we can just change it here. We want another animation to play slowly, and we just change the number here. So we do that by using this macro. Just we can have one animation type with different speeds, right? We can just put whatever speed we want in here. And that's what this this part of the code does. We have this timer thing, which is we compare that to whatever the current speed is for this sprite. If those are equal, so if the animation timer has counted up to whatever the speed, the current speed is right now, if the timer is equal to that, then we're going to reset the animation timer. So we just do that by loading A with 0, storing that into the sprite anim timer. This is a timer bit. Don't change the speed, just change this counter. But in addition to that, we say increment sprite anim frame counter. So we reset the timer itself, the little counting thing, but then we increase animation frame counter, which means we're going from 0 to 1 now, because we have displayed this frame as long as we wanted to. And when that's done, then we go over to the next frame. So that's why we increment whatever number is in here. So now we go from 0 to 1, so this number is going to be 1 now in sprite anim frame counter, which is this one. So and if sprite anim timer is not equal to sprite anim speed, so if the counting thing is not equal to the actual speed of the animation, then we just increase the animation timer. So just increase the counter and we jump check animation. So we just increase the timer and move on. It's really simple timer thing. So when we're done with all of that, increment x, compare x with 8. Have we reached number 8 now? No. Well, if we have, then we're done. If we haven't, then we jump up here and do it all over again, but now for sprite 1. And that's going to happen for sprite 1. Then we got down here, increase x, compare. We haven't reached 8 yet, so we go up here and do it again for sprite number 2, 3, 4, so on. So we're going to run that for all 8 sprites. And with that done, then we're done with the subroutine, which of course is going to bring us back to our main code. In this case, it's not the main code, it's the raster interrupt code. But let's just go back here for a second. So what if so last time when we were up here, we checked if the frame graphic number was 255. We looked at this, not end of animation, so we just updated the sprite pointer here. But what if it is 255? What's going to happen if it's actually the end of the animation? Well, in this case, I say load A with 0, store that in sprite anim frame counter, which is going to mean that if it's the end of the animation, in this case, if we have gotten all the way up here, so we have this, and we read in 255 here, then I'm going to set sprite anim frame counter to back to 0, which means we're going back to the first frame. So we're looping the animation, playing it over and over again. That's, in this case, that's what's going to happen when the animation is over, when you reach the last frame, you're gonna reset the animation. That's why I load 0 into Sprite Anim frame counter. So that's basically it. That's how this animation system works. So like I said, it might seem a little intimidating. The most important parts here is that you're really comfortable with the basics. Like I said, you have to be comfortable with working with assembly tables, and you should probably be really comfortable working with this 0-page thing, low byte, high byte, that kind of stuff, because this can get really confusing really fast. So if you know the basics, then the next step is just, when you're making something like this, think it through. You know, maybe just draw something on a piece of paper, think it through how you want that to work, and then you just use your assembly knowledge to make the actual code. So hopefully this made sense, and that's what I have for you today. So hopefully now this can help you do some sprite animation on Commodore 64. Alright, that's it for now. Have a great day. Bye bye.